Polar coordinates and rectangular coordinates are not two entirely separate things. There's actually a connection we can make between them geometrically. So here I've got a coordinate plane with our point O, or 0, 0, and I've made a triangle here with the point P, which I've labeled both r theta and x, y. So with this triangle, I've got x down here and y right here, and I've got r, the distance from O to P, right here on the hypotenuse, at an angle theta from this polar axis, which is the x-axis here as well. So, if we remember what we know about triangles in geometry, we know that the sine of an angle is equal to the ratio of the opposite over the hypotenuse, so sine of theta is y over r. And with cosine, it's just the adjacent of the hypotenuse, so it's going to be x over r. And if we think of tangent of an angle, we know it's the opposite over the adjacent, so tangent of theta is equal to y over x. And if you remember Pythagorean theorem, we have x squared plus y squared is r squared. That's like a squared plus b squared equals c squared, so we just have x squared plus y squared is equal to r squared. Okay, so just for you to remember, these are the formulas we get from what we just did. Instead of just x over r is equal to cosine theta, to find x, we just multiply the r on both sides and we come out with x equals r cosine theta. We can do the same. Down here we get y equals r sine of theta. And as before, we have x squared plus y squared equals r squared, and tangent of theta equals y over x. And these are the little formulas that are great to remember when you're doing these conversions. Okay, so here's an example where we're converting from polar coordinates to rectangular coordinates. So given the polar coordinates, 3 and r is 3 and theta is 5 pi over 6. So that's our angle. And we know that x equals r cosine theta, and we know that that y equals r sine theta. So we're given r and theta, and that's part of our formula here. So this is pretty simple. We can actually just take these values and substitute them into this formula. So we have x equals r cosine of theta. 3 is r, theta is 5 pi over 6, so 3 times the cosine of pi over 6, or 5 pi over 6, and that's going to give us negative 3 times the square root of 3 over 2. With y, we just take 3 times sine of 5 over 6, and that's going to give us 3 halves. So our rectangular coordinate, which would be x and y, is negative 3 times the square root of 3 over 2, and 3 halves.